In today's class and video, we are going to look at crystallization. So we'll start our introduction by looking at what crystallization is. So first of all, crystallization is the process of a liquid, solution, or gas turning into a solid or a crystal with a regular arrangement of atoms or molecules. Or crystallization is the process of separating solid compounds from solutions in the form of crystals. So let's see some of the uses of crystallization. So what you have to notice that crystallization is primarily employed as a separation technique to obtain pure crystals of a substance from an impure mixture. So example is to obtain pure salt from seawater and pure alum crystals from an impure alum. So these are some of the uses of crystallization, which involves the separation of pure crystals from an impure mixture. So now let's see the process involved in crystallization. Basically, we have four main processes or steps involved in crystallization. So the first is that the impure solid is dissolved in the required solvent. So as we can see from the diagram by, so this is the impure solid over here being dissolved in the required solvent. So the second step is that the solution is heated to evaporate most of the solvent. So this is the heat being applied to our solution over here. And this is the solvent being evaporated, as we can see over here. So the third step is that the hot solution is allowed to cool, resulting in the formation of pure crystals. So we cool the hot solution, and this helps in the formation of pure crystals. So as we can see at the bottom of the beaker over here, these are our pure crystals formed after allowing the hot solution to cool. And the fourth step is that the cold solution is poured off to obtain the crystals by pressing them between two sheets of filter papers. So this is our pure crystals on our filter paper as seen over here nicely. So what you also have to note in the process of crystallization is that undissolved solids or crystals formed in the liquid are separated by the process of filtration. So what it means is that if you want to separate these pure crystals from this solution over here after allowing it to cool, we use the process of filtration to do that. And also the size of the crystals formed during this process depends on the cooling rate. So what it means is that the cooling rate plays a key role in the crystallization process. So the tiny crystals are formed if the solution is cooled quickly or rapidly, and large crystals are formed at slow cooling rates. So what it means is that if you want small crystals, your cooling has to be rapidly or quickly. And if you also want large crystals, then that means you will have to what? Cool your you will have to cool your solution slowly. Let us look at the types and examples of crystallization. So the most frequently applied types of crystallization are the evaporative crystallization, the cooling crystallization from solution, and reactive crystallization or precipitation. So these are basically the three main types of crystallization. So now let us look at them one by one. So we'll start by looking at the evaporative crystallization. Evaporative crystallization is a process that uses heat to create a solid slurry product from a solution. And it's a common method for forming crystals from inorganic salts and sucrose. So let's see how evaporative crystallization works. So the first is that a solution containing the solvent and soluble component is heated. So the next is that the solvent evaporates, raising the concentration of the solution. So the solution becomes supersaturated, triggering nucleation, and the nuclei expand and unique crystals begins to form. So an example of the evaporative crystallization is heating salt water in an evaporating dish to leave salt crystals behind. And what you also have to notice that the termed nucleation is when a crystalline phase appears from a supersaturated solvent or supercooled liquid, and the term crystal growth is when the size of the particles increases, leading to a crystal state. So the next type of crystallization is the cooling crystallization. So the cooling crystallization is a process that involves lowering the temperature of a solution to cause the solute to crystallize out of the solution. And this process is commonly used in the pharmaceuticals and food industries. Cooling crystallization is suitable for substances whose solubility increases as the temperature rises. So this is a key point that we have to note under the cooling crystallization. The last is the reactive crystallization. Reactive crystallization is a chemical process that combines crystallization and reaction to create a desired chemical species. And this is also used by pharmaceuticals and fine chemicals companies to make finished products and intermediates. So now let's look at some factors that affect the rate of crystallization. So we have temperature, we have concentration, we have the nature of the crystallizing substance. We also have impurities present in the solutions. We have agitation, and we also have the nucleation rate. So these are some of the factors that affect crystallization. Thank you. So now let us look at the test protocols for the crystallization process in our experiment. So we'll start by looking at the materials needed. So we have the extraction solvent, filter papers, acetone, ice cubes, ice cold acetone, boiling water, boiling water bath, steam bath, stirring rod, and beakers. So one caution that we also have to take is that we have to note that the solvent that we are using, and these are the acetone, diethyl ether, chloroform, and hexane, cause eye and skin irritation. And this solvent vapors are also irritating to the mucous membrane and upper respiratory tract, and they are harmful if swallowed. Hence, this solvent must always be handled in the fume hood and closed immediately after use. So now let's start by looking at the test method for isolation of our crude by the crystallization process. So one, weigh 6 grams of the finely ground nut milk into a 100 ml Erlenmeyer flask. So add 40 ml of the extraction solvent, and this is hexane to isopropanol in the ratio of 3:2. And please just take note of the boiling point. 3. So warm on a water bath at 50 degrees Celsius in a fume hood. And after that, we mix well whilst heating for 15 minutes. So after heating for the 15 minutes, we filter through fluted filter paper into a pre-weighed beaker. So after that, we rinse the residue with 50 ml extraction solvent. Then we evaporate solvent from extract using a boiling water bath to obtain yellow oil or off-white solid for about 15 to 20 minutes. And finally, we weigh our crude extract.